Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Codes, DTC P0201 and P0204, indicate a malfunction in the injector circuits for the number 1 and number 4 cylinders, respectively. These codes signify that the engine control module, ECM, part of the programmed fuel injection, PGM FI system, has detected a problem with the electrical feed to each injector. The injectors play a crucial role in delivering fuel to the engine's combustion chambers, and proper functioning is vital for optimal engine performance. Potential consequences of a malfunction might include engine misfires, poor acceleration, increased emissions, and even engine damage under certain conditions. Location-wise, the number 1 injector pertains to the first cylinder, while the number 4 injector pertains to the 4th cylinder, typically located around the engine's intake manifold or fuel rail. Diagnosis must first ensure there are no underlying electrical issues that could be triggering these codes. The description for DTC P0201 refers to a malfunction in the injector circuit for the number 1 cylinder, while DTC P0204 points to an issue in the circuit for the number 4 cylinder. Each injector is responsible for injecting fuel into its corresponding cylinder to ensure proper combustion. The injectors for both cylinders are typically situated on the engine's fuel rail, aligning with the intake manifold. An effective firing order and timely fuel delivery are vital for engine efficiency and performance. Thus, any issues here can lead to significant engine behavior problems. The Powertrain Control Module, PCM, uses feedback from sensors to monitor injector operation, and any discrepancies can trigger the DTCs mentioned. Identification of these codes is a prompt to assess electrical connections, wiring, and the injectors themselves to understand where failures might reside. The possible causes for DTC P0201 and P0204 include several electrical anomalies that can compromise injector circuit functionality. An injector malfunction could occur due to internal failures or blockages within the injector assembly itself. A faulty relay could disrupt the power supply necessary for the injectors to operate, or wiring issues such as frayed or broken wires could impede electrical flow. Open circuits represent breaks in the wiring that prevent the signal from reaching the injectors or relay. Additionally, shorts to power can occur if the wiring touches a power source, leading to overvoltage situations, while shorts to ground can create unintended pathways that disrupt normal operation. Each of these issues must be systematically checked during the troubleshooting process. The presence of DTC P0201 and P0204 often manifests as symptoms affecting vehicle operation. Owners may experience an engine misfire, which is characterized by sporadic or uneven engine sounds and vibrations, often accompanied by a rough idle. Such symptoms can lead to poor acceleration as the vehicle struggles to gain speed effectively. Additionally, there is an increased risk of elevated emissions, leading to potential environmental compliance issues. Drivers may also notice the check engine light illuminating on the dashboard, a clear signal that the vehicle's onboard diagnostic system has identified an issue that requires further investigation. These symptoms serve as indicators that immediate attention is necessary to avoid further damage to the engine and related components. In the first troubleshooting step for DTC P0201 and P0204, you need to verify the issue initially. Begin by turning the vehicle ignition to the on position without starting the engine. This allows the vehicle systems to power up and prepare for diagnostics. Next, use the Honda Diagnostic System HDS to clear any existing diagnostic trouble codes. This step is vital to ensure that you are only addressing current problems and not lingering codes. After clearing the DTCs, attempt to start the engine. If it does not start, crank the engine for a minimum of 20 seconds to assess if it can ignite. Following this, check the HDS again for any pending or confirmed DTCs. If DTC P0201 or P0204 reappears, proceed to the next diagnostic step. If neither DTC appears, further investigate potential intermittent failures or poor connections. For the second troubleshooting step, you will check if the engine can start following your previous actions. This is an integral part of the diagnosis process, as it helps isolate the issue to either a potential electrical fault or a deeper mechanical problem. Try starting the engine. If it starts successfully, this indicates that the initial condition may have resolved itself, suggesting moving on to further diagnostics in Step 11. Without concern for DTC P0201 or P0204. However, if the engine does not start, it suggests that there could be significant concerns that should be explored in the following steps. This decision-making process is crucial, as understanding whether the engine's ignition is functional can help pinpoint the root cause of the issue. In the third troubleshooting step for DTC P0201 and P0204, begin by switching the vehicle to the off or lock mode. This is important for safety and prevents electrical shorts when working on the vehicle's wiring system. Next, you will need to remove the injector relay from its socket, allowing you to access the connection and circuitry associated with it. Use a multimeter to test the injector relay to see if it is functioning correctly. This relay plays a critical role in vehicle operation by controlling power to the injectors. Should the testing indicate that the relay is functioning properly, you can then proceed to the next step, which checks the wiring around the injectors. If the relay shows faults, it will require replacement, as this is integral for the proper operation of the injector circuits. The fourth troubleshooting step involves checking for battery voltage in the +B IGP line. Switch the vehicle to off or lock mode, ensuring that it is safe to conduct measurements. With the injector relay still disconnected, you will need to measure the voltage between two specific test points. Test point 1 corresponds to the injector relay 4P socket's female terminal number 3, while test point 2 connects to a suitable body ground. Using a multimeter, measure the voltage to see if there is a steady battery voltage present. If yes, this indicates that the +B IGP wire is functioning properly, and you can move on to subsequent steps to diagnose the injectors or additional wiring. In contrast, if no voltage is detected, a further examination involving the checking of fuses is necessary, as it may point to damage or disconnection within the circuit. For the fifth troubleshooting step, focus on inspecting fuse number A13. This fuse is critical for the injector circuit and can result in DTC P0201 and P0204 if blown. Ensure your vehicle is off or in the lock mode before opening the fuse panel, as this ensures safety while performing visual inspections. After identifying the correct fuse, check for any visual damage indicating it is blown, which typically appears as a broken filament or discolored casing. If the fuse is operative and shows no signs of damage, you will need to repair any breaks in the +B IGP wire between this fuse and the injector relay. However, if the fuse is indeed blown, both the fuse must be replaced and the short condition causing the break must be resolved to restore normal function. The sixth troubleshooting step focuses on checking the voltage on the +B INJ line. Like previous electrical inspections, ensure the vehicle is in off or lock mode for safety. The injector relay should remain disconnected during this measurement. For accuracy, Measure between test point 1 at the injector relay 4P socket's terminal number 1 and test point 2, which should connect to a body ground. Again, utilize a multimeter to detect battery voltage. If voltage is present, it indicates that the +B INJ wire is functioning correctly and allows you to progress to later steps. If battery voltage is absent, you will need to inspect fuse number A11 and wiring for issues that could obstruct the signal reaching the injectors. During the 7th troubleshooting step, inspect fuse number A11, essential for maintaining the functionality of the +B INJ line. Switch the vehicle to off to safely conduct this examination while ensuring the fuse panel is accessible. After locating fuse number A11, visually inspect it for any signs of wear or damage. If the fuse appears to be blown, replace it immediately. However, if it is intact, you should look for an open issue in the +B INJ wire between fuse number A11 and the injector relay. This may require further investigation of wire integrity and connections to identify the specific areas requiring repair. In the 8th troubleshooting step, you are determining the condition of the FI main RLYCL line. Switch the vehicle to the on mode and ensure the injector relay is disconnected for accurate results. Measure the voltage between two test points on the injector relay 4P socket, one at female terminal number 3 and the other at female terminal number 4. The presence of battery voltage at these points indicates that the fuel injection main relay is operational and likely serving its purpose. If battery voltage is detected, you can proceed directly to later troubleshooting steps. However, if no voltage is present, you'll need to check the wiring integrity further, which may require checking for continuity or further inspections of the relevant components. For the 9th troubleshooting step, check for continuity within the FI main RLYCL line. This process begins with the vehicle in the off or lock mode to avoid potential electrical shorts. Utilizing the HDS, jump the SCS line and wait for more than 1 minute to ensure cleared codes are accurately assessed. After this, and with all connectors correctly disconnected, check continuity between the designated test points on the injector relay socket and the PCM connector A. Confirm continuity to indicate that this wire does not have open issues. If continuity exists, this wire is operational, but if absent, the FI main RLYCL wire will need to be repaired between the PCM and the injector relay to restore functionality. In the 10th troubleshooting step, the focus shifts to the INJ outline. Turn the vehicle to off and create a bridge between terminals A and B on the injector relay's 4P socket, where terminal A corresponds to terminal number 1 and terminal B to terminal number 2. As before, using the HDS, jump the SCS line, waiting more than a minute before proceeding. Once complete, you will measure the voltage between two newly designated test points at the PCM connector, looking for battery voltage. If battery voltage is present, this indicates a functioning INJ out circuit, allowing you to continue troubleshooting. If found absent, an open in the INJ out wire between the PCM and the injector relay will require detailed examination and repair. The 11th troubleshooting step necessitates a revisit to the diagnostic codes identified in Step 1. This is pivotal since it allows you to narrow down which specific cylinder injector circuit is affected. Using the HDS, check the displayed DTC codes and determine if DTC P0201 remains active. If it is present, you will progress to the next corrective measures, directed specifically at the number 1 injector circuit. Conversely, if DTC P0201 does not appear, shift attention to DTC P0204 and follow the respective steps related to that code. These checks allow you to tailor your subsequent troubleshooting steps efficiently, targeting the precise component or wiring involved. The 12th troubleshooting step requires checking the INJH1 line and INJL1 line for continuity. You should start this process with the vehicle in the off or lock mode, and the injector relay must be reinstalled for you to proceed effectively. After that, use the HDS to jump the SCS line for a minute, then disconnect the designated PCM connector E. Measuring continuity between the selected test points on the respective connectors will confirm the status of both lines. If continuity is detected, this indicates that the connections are sound, allowing you to move on to subsequent steps. However, if continuity is absent, repairs will need to be made to the INJH1 wire leading to the number 1 injector. In the 13th troubleshooting step, you'll focus specifically on the INJH1 line by checking its continuity via the number 1 injector's connector. Ensure that you have disconnected the relevant connector while the vehicle is in off mode, which allows safe handling of electrical components. Measure continuity from the female terminal of the number 1 injector to the appropriate point on the PCM connector E. If continuity exists, you will be informed that the INJH1 wire is intact, enabling you to continue troubleshooting. Should continuity not be present, further investigation is necessary to repair any open wiring issues between the PCM and the number 1 injector. During the 14th troubleshooting step, the focus shifts to the INJL1 line. It's crucial to maintain the vehicle in the off mode, with all relevant PCM and injector connectors disconnected for a thorough measurement. You will check between the specified points on the number 1 injector's connector and the appropriate PCM point. If continuity is confirmed, this suggests that the INJL1 wire maintains operational integrity, confirming that the wiring leading to the number 1 injector is sound. Upon finding continuity, you should proceed to replace the number 1 injector, as it may be the cause of the DTC. Conversely, if continuity does not exist, repairs to the INJL1 wire will need to be undertaken to restore functionality. The 15th troubleshooting step requires checking for short circuits in the INJH1 line. Start by disconnecting the number 1 injector connector and ensuring the vehicle is in the on mode. Utilize your multimeter to measure the voltage between the specified terminals on the PCM disconnect and body ground. If any voltage is detected, this indicates an undesirable short to power within the INJH1 wire, suggesting that repairs will be necessary to eliminate this fault. Conversely, if no voltage is measured, you will need to progress to look for issues related to the INJL1 wire under similar testing protocols, ensuring all potential faults are addressed comprehensively. Step 16 continues with the examination of the INJL1 line for shorts to power. Begin the process under the same conditions as Step 15, maintaining the vehicle in the on mode and with the injector connector still disconnected. Again, measure the voltage between the predetermined test points on the PCM. If there is voltage present, this signifies a short to power condition in the INJL1 wire, necessitating repairs to the wiring insulation or connections to rectify the issue effectively. On the other hand, if no voltage is observed, you must look to the next steps in your diagnostic path to ensure all relevant circuits are properly functioning and checked. In the 17th troubleshooting step, the focus is on checking the INJH1 wire for shorts to ground. Make sure the vehicle is off while you perform this continuity check between specified test points on the PCM connector and ground. If continuity is confirmed, it indicates a short to ground in the INJH1 wire exists, requiring immediate repairs to negate this fault. However, if no continuity exists, You then proceed to methodically check the NJL1 line for similar conditions, ensuring that all discrepancies in wiring integrity are addressed. In the 18th troubleshooting step, you're tasked with verifying the integrity of the INJL1 line against ground. This check should be performed with the vehicle off and all relevant connectors removed for safe examination. Measure continuity between the specified test points on the PCM connector and ground. Once again, if continuity is present, it suggests the INJL1 wire is intact, and you should move on to exploring the potential directive for the next injector circuit issues. If continuity is absent, however, repairs to the INJL1 wire will need to be done to restore functionality. The 19th troubleshooting step involves checking the INJH4 line for continuity while ensuring the number 4 injector is disconnected. Maintain the vehicle in the off mode for safety during this examination. Measure between the specified test points on the PCM connector and the number 4 injector connector in search of continuity. If continuity exists, this suggests that the INJH4 line remains intact, allowing you to advance towards further tests. Conversely, if continuity is absent, it indicates an open circuit that will necessitate repairs between the PCM and the number 4 injector. During the 20th troubleshooting step, you are tasked with checking the continuity of the INJH4 and INJL4 lines. Similar to previous steps, ensure that the vehicle is in the off mode. Reinstall the injector relay for proper testing and proceed to examine continuity with the designated points on the PCM connector. If continuity exists, both lines are sound, and you can continue with additional checks as per your specific protocols. If not, investigate physical wiring between the injector and the PCM for any obstructions or damages. In the 21st troubleshooting step, concentrate on ensuring continuity within the INJH4 line, specifically with the number 4 injector disconnected. Keeping the vehicle off for safety, measure the continuity between the number 4 injector connector and the PCM connector points. If the test reveals continuity, this confirms the wiring is intact and that external factors might be at play, requiring alternative diagnostics. Alternatively, should the continuity test fail, it necessitates repairs to the INJH4 wire between the PCM and the number 4 injector. During the 22nd troubleshooting step, you'll assess the NJL4 line. This process mirrors the previous issues checked, but focuses directly on the NJL4 line, ensuring all relevant connectors are appropriately handled. With the vehicle off, check for continuity between the number 4 injector's terminals and the corresponding PCM connector points. If continuity is identified, this suggests that the NJL4 wire is functioning effectively, and you should then consider replacing the number 4 injector as it may be faulty. However, should continuity not be present, this line will entail repairs to restore functionality. Step 23 revolves around checking for shorts within the NJH4 wire. Under on-vehicle conditions, disconnect the number 4 injector connector, keeping safety as a priority during voltage testing. Measure voltage against a body ground and check between the specific PCM connectors. Presence of voltage indicates that there is a short to power condition in the NJH4 line, mandating repairs to correct the fault. Should no voltage be detected, you can proceed to similar tests for the NJL4 line in your continuing diagnostic procedures. In step 24, the focus is on identifying short conditions within the INJL4 wire. The same methodology from previous steps applies. Keep the vehicle in the on mode while the number 4 injector connector is disconnected. Measure the voltage between designated points on the PCM connector and body ground. If you discover voltage, it indicates a short to a power condition in the INJL4 wire, requiring appropriate repairs to rectify the error. If no voltage is detected, assess other wiring paths or components to ensure complete diagnostic coverage. The 25th troubleshooting step necessitates checking the INJH4 line for shorts to ground. With the vehicle in off mode, continuity should be established between the PCM connector and ground for proper assessment. If continuity is confirmed, this indicates a short circuit to ground condition present within the INJH4 wire, requiring immediate repair efforts. Should continuity not be established, it indicates that the wiring remains intact and may not need replacements, allowing for other diagnostic areas to be explored. Step 26 mirrors the previous step, but focuses specifically on the INJL4 line for shorts to ground. Again, starting with the vehicle in off mode, verify continuity across the wire from the PCM connector to ground. If you determine continuity is present, this may point towards a fault that needs correcting due to shorts affecting performance. However, if found to not be present, you can rule out this wire as a cause, urging you to engage in alternative areas for potential injector faults. In the final step, you will check the INJH1 line for continuity, tying back into the injector component infrastructure. The number 1 injector connector should be disengaged with the vehicle in off mode as you proceed to measure durability across the wire. You should ensure continuity between the PCM connector points and the number 1 injector to ascertain wiring viability. If it remains intact, a thorough review of the injector could unveil issues requiring resolution. If continuity isn't found, it indicates wiring problems which could necessitate repairs based on the present conditions. After completing the relevant repairs associated with DTC P0201 and P0204, a final verification of the repairs must be conducted. Start by verifying that all repaired circuits and connections are secure and functioning as intended. Utilize the HDS to clear the previously stored DTCs, allowing the system to reset and establish a new baseline of operations. Following this reset, perform a test drive of the vehicle to observe its overall responsiveness and ensure that no warnings or performance faults arise. Monitor the vehicle carefully for any recurrence of the DTCs to confirm that the issue has been adequately addressed and that the correct measure has resolved the malfunctions. Successful repairs will reflect in improved engine performance without illuminated warning lights. Preventive maintenance is essential for avoiding future incidents related to DTC P0201 and P0204. Regular checks on the injectors should be prioritized, ensuring they are clean and free from blockages or malfunctions that can hinder performance. Inspect wiring and connectors routinely, checking for any signs of wear, corrosion, or damage that could lead to shorts or open circuit conditions, which are common causes for DTCs in these contexts. Moreover, ensuring the use of high-quality fuel in the vehicle helps maintain the integrity of the fuel injection system, directly supporting performance and reducing the risk of internal injector wear. Regular maintenance routines can significantly enhance vehicle longevity and operational reliability. In conclusion, addressing DTC P0201 and P0204 involves understanding the specific injector circuit malfunctions indicated by these codes. Familiarizing oneself with the likely symptoms allows a swift identification of issues and functionality, aiding in timely troubleshooting. Following the structured troubleshooting steps outlined helps diagnose and rectify identified faults efficiently, thereby reducing vehicle downtime. Lastly, implementing preventive maintenance measures minimizes the likelihood of future occurrences of similar issues, ensuring ongoing operational efficiency and reliability from the Honda Accord. Proper care and attention to the injector circuits can lead to enhanced performance, reduced emissions, and overall better vehicle lifespan. Please like and subscribe to the channel. See you next time.